A water wheel spins clockwise at a rate of 90 complete revolutions per 60 minutes. The radius of the water wheel is 12 feet. The center is built 8 feet above water level. One of the spokes of the water wheel is painted green. Which of the following sinusoidal functions models the height of the edge of the green spoke h with respect to time in minutes denoted as m? So this is a calculator problem. I ain't going to use it. Sine reg here, which is, sinusoidal regression, just like linear regression, just like quadratic and exponential, all that stuff, ln reg, I guess you could use it. But it's sine reg you're going to want to use when you're given a bunch of points. I'm not given any points here, so I'm not going to use sine reg. So I'm going to use my human calculator, my brain. Now, I like to create a picture whenever I deal with these and use that picture as my guide. What do I have? Well, the green spoke is right here at the middle. Okay, so I have a midline, and my midline is 8 feet above water level. So my midline is going to be at 8. So let's put an 8 right there. There is my midline. Hooray. Now, whenever you're given a sinusoidal problem and you are given a radius, that radius is your amplitude. So what's going to happen is as this guy turns counterclockwise, you're going to hit a tippy top. And that tippy top is going to be the length of the radius. So 12 plus that radius is going to be 20 feet up in the air. So that's going to be my maximum, is 20. As this guy goes underwater, it's going to go under 12 taken away from 6, which means it's going to bottom out at -4. And if you're thinking, whoa, buddy, you can't have negatives for real-life sinusoidal problems. You sure can if you're going underwater, and this looks like it's underwater to me. So I'm going to go with that. Now, as this rotates counterclockwise, you are starting at the midline and moving up and then down, and then up and then down. So you're starting at the midline and you're moving up and then down, and then up, and then I'm out of space. Okay. Now, that, to me, looks like a sine. A sine, I know here it starts at 8, but a sine starts at usually the x-axis, or in this case, the midline. It starts right there at that origin point and goes up and down and up and down and blah, blah, blah. So this is sine. So, I guess we have no choice, but it is sine. Now, what this means is as I start to build this equation, I know one thing I don't have. Now, what I do have is I have an amplitude. I have a midline. What I need to do is figure out what my period is. Now, if I'm looking at all this and trying to write an equation, I'm comparing it to y equals a parentheses sine parentheses b parentheses x minus c, close it. Actually, I really don't like that parentheses there. Let's get rid of you. Close it, and then plus d at the end. Okay? Now, what's what? Well, you're my amplitude. I already know that. So my amplitude is 12. You're my midline. I already know that. What I also know is since this is starting at sine, I'm not going to have a horizontal transformation or translation. I'm not going to move left or right anywhere. Okay, so that minus c is useless. What I don't have is b. B is the frequency. B is not the period. I'm going to have a hard time trying to figure out using these numbers what the frequency are. So what I'll do instead is I will find out what the period is. Now the period lives right here where it starts over. If this guy is going to do 90 things in a course of 60 minutes, that means this number right here is going to be 60 over 90, which is 2/3. Now, does that mean I'm going to do 2/3 here? No, that's not even an option. That's my frequency. The way, actually I do, well, I don't, it's 90 over 60. Oh, that was a close one. What I need to do is I need to find out what my frequency is. Now, my frequency is found out by doing 2 pi over the period, which is 2/3. Okay, multiply the top and the bottom by 3 halves rather, it's reciprocal. So that crosses out, that crosses out, that crosses out, that crosses out. I now have 2 pi times 3 over 2. So the 2's cross out, and I'm left with 3 pi. So my period is 3 pi. So putting this all together and using h of m and using m instead of x, I have h of m equals 12 sine 3 pi x, because I don't have a horizontal translation, or m plus 8. So that's problem number 40 in our multiple choice test. Okay, could I use a calculator? Probably, but I just, I didn't want to because I didn't need to. And sinusoidal regression is just not fun if you don't have any points. This, however, is fun. So 40 problems down. This is a typical practice test, what it would look like. Hope this helps.